Alright, so let's assume that we have a situation in which a boat, right, it's going close to a beach, and we want to, well, someone's going to jump from the boat and swim to the beach, and we want to find then what's the shortest path. So what's the point in this line which would be the closest to a certain point at the beach. So with the knowledge that we have gathered of lines, we could understand this as a perpendicular line towards the beach. And then we should be able to find a point here. I'll call this point S. So we could express a vector relation between this vector B, which is the direction vector of this line, and this other vector here. So PS, which is our vector pointing from the beach, if we do the dot product with vector B, which is our direction vector, it should be 0 because they are perpendicular. Now point S has a special name. It's also called the foot of the perpendicular from P to the line. Okay, it's the foot. So let's take a look at one example. So a line vector has this equation, right? And so x and y is, so x is 1 plus 3t and y is 2 minus t, and t is a real number. Now let P be the point 5 and negative 1. Let's find exactly the shortest distance from P to the line. So first of all, if we assume, let's assume there's a point N in this line, and this point N for a certain t would have x equals 1 plus 3t and y equals 2 minus t. Okay, so those are the coordinates of this point N, and let's assume now that this point N is the foot of our vector. So it's the shortest distance. It's going to be the point which is going to give us the shortest distance to point P. So if we assume that, let's first describe. So if this was our line, let's just assume if this was our line, this would be some point P, and we basically have found, okay, this point N is going to be the one which is going to give us some perpendicular vector, right? Some perpendicular, NP is going to be perpendicular to the direction vector of this line. Okay, the line itself might be different, but this is the whole idea. So from this, we should have that the vector NP dot product with B should be 0. Now, how can we find NP? So we have the coordinates of point P. So NP would be coordinates of point P minus coordinates of point N. Remember that here you can do NP or PN. It doesn't matter, because it doesn't matter the direction as long as the angle is 90 degrees. So let's see. 5 minus 1 plus 3t, 1 minus 3t, right? So 5 coordinate of the point P minus coordinate of point N, and let's put in vector form, and negative 1 minus coordinates of point of the y coordinates of our point N. Alright, so that's NP. If we simplify that, we should get 4 minus 3t and negative 3 plus t. That's our vector NP. Now, vector B is the direction vector of our original line, so this is our direction vector. So if we make the dot product, we should have 3 times, so we just multiply this by what we have here, right? So let's put this in full vector form. So from this, what we get, product with 4 minus 3t and negative 3 plus t. Now dot product, we basically just multiply the coordinates. So 3 times 4 minus 3t plus negative 1 times negative 3 plus t. And this should be 0 since they are perpendicular. And there we go. Now it's a very simple system. 3 times 4, 12. 3 times negative 3, negative 9. Negative 1 times negative 3, that's positive 3. And negative 1 times positive t is negative t. And that's equal to 0. So negative 10t is equal to negative 15. Therefore, t is equal to 1.5. Now, since the question is asking us for the shortest distance, we still have to calculate the magnitude of NP, right? NP is the vector which points from the closest point to this point P. So we have to get the magnitude to find this distance, which will be the shortest one. Cool? So NP would be root, and now we can get these numbers into our vector NP, right? If we apply t equals 1.5, what would be NP then? Well, 4 minus 3 times 1.5 and negative 3 minus plus 1.5. So we should have 3 times 1.5 is 4.5, 4 minus 4.5, negative 0.5. And negative 3 plus 1.5, that would be negative 1.5. That's our vector, right? So if we calculate the magnitude, should be negative 0.5 squared plus negative 1.5 squared. And if we work down the numbers, we should get root of 10 over 2, or approximately 1.58.